Git branches cost nothing. Literally, they're just 41-byte files pointing to a commit. This makes branching Git's killer feature, and understanding it will change how you write code. Let's dive in. A branch in Git is just a pointer to a commit. It's a tiny 41-byte file containing SHA hash. To create one, run git branch feature login. To switch to it, use git switch, which is the modern way, or git checkout, the classic approach. Head is a special pointer that tells Git which branch you're currently on. You can list branches with git branch, rename with -m, and delete with -d for safe delete, or -D to force delete even unmerged branches. Fun fact, Git checkout used to do too many things. Git 2.23 introduced git switch for changing branches, and git restore for restoring files, splitting the responsibilities. Merging brings branches back together. Run git merge feature login from your target branch. There are two types. A fast-forward merge happens when branches haven't diverged. Git just moves the pointer forward. No merge commit needed. A three-way merge happens when both branches have new commits. Git creates a merge commit with two parents. The no flag forces a merge commit even when fast-forward is possible. Some teams enforce this for cleaner history. The FF-only flag refuses to merge if fast-forward isn't possible, useful for cautious workflows. Merge conflicts happen when two branches modify the same lines in the same file. Git marks conflicts with angle bracket markers, less than signs for head, equal signs as the divider, and greater than signs for the incoming branch. To resolve, edit the file to keep what you want, remove the markers, git add the file, and git commit. Use git merge a tool to launch a visual merge tool, or git merge -- abort to cancel entirely. Here's a quirk. Git conflicts on the exact same line, but not on adjacent lines. The diff algorithm uses context windows, so editing line 10 and line 11 in different branches won't conflict. Git rebase replays your commits on top of another branch. Instead of merging, which creates a merge commit, rebase moves your work forward to create a clean, linear history. Before rebase, your feature branch diverges from main. After, it looks like you started from the latest main commit. The key difference: merge preserves branch topology and is non-destructive, while rebase creates a linear history, but rewrites commits with new SHA hashes. The golden rule: never rebase branches that others are working on. If a rebase goes wrong, use -- abort to cancel, -- continue after fixing conflicts, or -- skip to bypass a problematic commit. Interactive rebase is arguably the most powerful Git command. Run git rebase -I had ~4 to rewrite your last 4 commits. You get several actions. Pick keeps a commit as is, reword changes the message, edit pauses so you can amend, squash merges into the previous commit keeping both messages, fix up merges, but discards the message, and drop removes the commit entirely. This is perfect for cleaning up messy work in progress commits before sharing. Use git commit -- fixup with auto squash to automatically mark commits for squashing. And here's a power move. Git rebase -I -exec npm test runs your test suite after every single rebase commit. Git cherry pick copies a specific commit from one branch to another. Run git cherry pick followed by the commit SHA. It's surgical, you pick exactly the commits you need. The -x flag records the source commit and the message for traceability. You can cherry pick a range of commits using -- syntax. But beware, cherry-picked commits get entirely new SHA hashes. Git sees them as unrelated to the originals. If you later merge the source branch, you might get duplicate changes. Let's recap. Branches are cheap 41-byte pointers. Create them freely. Merge preserves history with merge commits, while rebase creates clean linear history. Interactive rebase is your best friend for cleaning up commits before sharing. Cherry pick lets you surgically transplant specific commits. And remember the golden rule: never rebase public or shared branches. Next up, Part 3, Working with Remotes, where we'll cover pushing, pulling, and collaborating with others.